Okay, this question gives us a reaction where N2 gas reacts with 3 hydrogen gases to make 2 ammonias, NH3 gas. And they give us the overall standard enthalpy change for this reaction as negative 91.8 kilojoules per mole. Now what they're asking us for is to calculate the standard heat of formation of ammonia. So they're looking for delta H formation standard for NH3. Okay, whenever they ask for heats of formation and you have an enthalpy overall of a reaction, we're going to go ahead and say the enthalpy change of our overall reaction equals the sum of all the heats of formation of your products minus the sum of all the enthalpies of formation of your reactants. Of course, each of those is multiplied by the coefficient as given in the balance equation. Let's go ahead and write that equation down now. The overall enthalpy change for this reaction under standard conditions is the sum of all the heats of formation of my products multiplied by the number of moles minus the sum of all the enthalpies of formation of my reactants multiplied by the number of moles. Now in this particular question, we have the overall enthalpy of reaction. It's negative 91.8. I'm going to go ahead and substitute that in there right now. Negative 91.8 kilojoules per mole equals, well, let's go ahead and start with our products. Our products is the ammonia. So we're going to take the balanced chemical coefficient 2 times the heat of formation of NH3 plus, okay, we don't have any more products, so we don't do anything else. So we take our products minus 1 times the standard heat of formation of nitrogen. Now they didn't give that to me, but that's okay. Under standard conditions, the heat of formation of any element happens to be 0. So I'm just going to go ahead and say this one is 0 minus the next reactant. We have a coefficient of 3, and that's hydrogen, another element under standard conditions. So we're also going to call that heat of formation 0. So right now I have negative 91.8 kilojoules per mole equals 2 times the heat of formation of NH3. Okay, all we need to do is go ahead and divide our answer by 2. If we do that, we get an enthalpy change, a standard heat of formation of NH3 as a negative 45.9 kilojoules per mole. So all we needed to do was take this reaction and go ahead, divide it by 2. Wait a second, that actually makes sense because this is almost a formation reaction. All that has to happen for us to call this a formation reaction is we need to make not 2 moles of ammonia from the elements, but we need to make 1 mole of ammonia from its elements. So if I took this particular reaction and I multiplied everything by a half, let me rewrite it. I would have had 1/2 N2 gas plus 3/2 H2 as a gas goes to 1 single NH3 as a gas. If I multiply everything in this reaction by a half, I just multiply the heat of reaction or the enthalpy change of this reaction by a half. So this is 1/2 times a negative 91.8 kilojoules per mole. And since this particular reaction as written is a formation reaction, I could call this a standard heat of formation, a half of what we have. That's just what we did. So it all checks out and it all makes sense. I hope that helps. Take care.